A projectile is fired at an angle of 45 degree with the horizontal. Elevation angle of the projectile at its highest point as seen from the point of projection is. So basically what been given here is, say this is the ground. An object is projected from A, say with respect to the ground as 45 degree, right? So how will the object move? So the object will move in a projectile motion. It will reach the maximum height P. It will then reach to ground at C. We know, let us, if this point is T, we know that this complete horizontal distance traveled is what we call as R, which is the range, and this much is the maximum height H. And if we draw a parallel line here to the maximum height, and the line joining the point and the maximum height, in which case this angle is what we call as the angle of elevation, or which is equal to this angle, which is the angle of elevation. So from the figure we can say that tan E is equal to BD by AD, which is equal to H by AD, we know is R by 2, right? So we H by R by 2. Now at 45 degrees, what is the relationship between H and R? At 45 degree, 4H is equal to R. So we can say that this will be equal to H by, instead of R, now I can write it as 4H by 2. So this will further be equal to H by 2H. So H and H will cancel, we get 1 by 2. So if tan E is equal to 1 by 2, what is E is equal to? E will be tan inverse 1 by 2. Therefore the correct option is option C. What is H is equal to? H we know is U square sine square theta by 2g. And what is R is equal to? R is U square sine 2 theta by g. Now what is theta? Theta is the, what is theta? Theta is the angle of projection, which is given us to be here as 45. In which case, what is H is equal to? H is U square sine square 45 the whole upon 2g, and R is equal to U square sine 2 into theta. 245 is 90 the whole upon g. So if you divide H by R, what do you get? U square sine square 45. What is sine 45? Sine 45 is 1 by root 2. So what is sine square 45? It is 1 by root 2 the whole square, that is 1 by 2. So this can be written as U square by 4g, because 1 by root 2 the whole square into 1 by 2. 1 by 2 the whole square is 2. 2 into 2 is 4. So we have U square by 4g. Sorry, let us write H is equal to U square by 4g. And what is R is equal to? Sine 90 is 1. So we get this as U square by g. Now what is H by R is equal to? H by R will be equal to U square by 4g into g by U square, which is equal to U square, and by U square is 1, g by g is 1. So what we get is 1 by 4. So that is how we get 4H is equal to R. So I think that part is also clear. Now what some students may feel, or what may be eager to know, is how is AD equal to R by 2? So let us take a brief look into that part also, because that will complete almost every doubt from this corner. So say, okay, let me get these things out from the board now. Okay, so now if you have to say that AC is R and AD is R by 2, how does it happen? Let us see. See, when you project a body in a projectile, okay, that would be wrong to say. When you project a body at an angle theta with velocity u, it can be resolved into two different components. One is x component ux and other is the y component uy, right? So throughout the motion, there will be horizontal acceleration and vertical acceleration as well. Okay. Now, what is horizontal acceleration here? Horizontal acceleration is 0 and vertical acceleration throughout the motion will be minus t. So there is only one acceleration, one component of acceleration acting, which is the vertical acceleration. So on the basis of this, if you write the third equation of motion, what do we get? Sx is equal to ux into t plus half ax into t square, right? Now, is there any ax component here? No, because ax is equal to 0. So what do we have here? We have that Sx is equal to ux into t. Now, if we assume Ta to be the time of ascent, and if we assume capital T to be the time of flight, Ta to be the time of ascent. Now, what does it mean? It means the time taken by the body to reach B from A. What is time of flight? It is the time taken by the body to reach C from A, which means time taken to cover A to B and then B to C. So, what is Sx corresponding to Ta? Let us see. Time of ascent is this time taken to reach A to B. What is Sx? The horizontal displacement in that time. So when we say horizontal displacement when it has reached B, the corresponding position is D, and therefore the horizontal displacement is the final position minus the initial position, which is AD. Therefore, Sx at time of ascent is equal to AD. Similarly, when we say time of flight, it means the entire motion from A to C. So when at A to C, this is the final position, initial position A, and the final position is C, and therefore what will be the final displacement? Final position minus initial position, which is C, right? So the time of flight distance, horizontal displacement during the time of flight is Sx would be equal to AC. So now let us write down these two equations again. So Xx at t is equal to A will be equal to ux into Ta, and Sx at t is equal to capital T will be equal to ux into capital T, right? So now you may ask me, won't ux vary? See, ux won't vary. Why? Because ux is equal to ux is a constant. Why is ux constant? Because the horizontal acceleration is 0 throughout. So now if you divide these two equations, what do you get? What you get is interesting. Why? Sx at t is equal to A, the whole upon Sx at t is equal to t is equal to Ta by t. Now what is Sx at t is equal to A? It is, we written it as AD. So we have AD by, what is Sx at t is equal to t? It is AC is equal to Ta by, what is time of flight? Otherwise, time of flight is basically, we know that it is 2 times time of ascent. So this becomes 1 by 2. So in short, what we get is AD is equal to half into AC. Now from the figure, right, we know that AC is R. So if we substitute AD is equal to half AC, if we bring AC here, instead of AC, we can write it as R. So what we write here is AD is R by 2, right? So AD is R by 2, and that is how we write AD here as R by 2. So now again a question comes up, how is time of flight is equal to 2 times time of ascent? let us discuss it maybe somewhere another problem when the same concept regarding time of flight comes up. A particle moves in a circle of radius 5 centimeter with constant speed and time period 0.2, it's 0.2 pi seconds. The acceleration of the particle is, so very simple question. So we know that a net is equal to root of AC square plus AT square. What is AC? AC is centripetal acceleration, and what is AT? Is tangential acceleration. Now here a net would be equal to root of AC square plus, see, since it is given that the object is moving with constant speed, right, the constant speed which is v is equal to k, implies the tangential acceleration will be equal to 0. So what we get is a net is equal to AC square, sorry, root of AC square, which is AC. And what is AC? AC is omega square into r. What is omega? Omega is 2 pi by t. So this becomes 2 pi by t the whole square into r. So this is 4 pi square by t square into r. So we can write this as 4 pi square. How much is t? T is given to it as 0.2. This becomes 0.2 square into pi square into r is 5 centimeter. So that is 5 10 to the power minus 2. So what do you get by solving this? This is equal to pi square by pi square is 1. So what we get is 4 into 5 into 10 to the power minus 2 the whole upon 0.2 square can be written as 4 into 10 to the power minus 2, right? So now 10 to the power minus 2 by is 1, 4 by 4 is 1, so what you get is 5, which makes the correct option as option D, 5 meter per second square. So now you may think, why did I convert 5 into 10 to the power minus 2? Because the option says only meter per second square, whereas what's given to us is 5 centimeter. Okay. See, I would actually suggest that while try solving this question, you should learn a couple of things in addition to this, which will help you in improvising your concepts. We'll discuss that as 3 cases. So, circular motion can primarily be divided into 2 types. One is uniform circular motion and the other is non-uniform circular motion. Now non-uniform circular motion would be again of 2 types: accelerated circular motion and retarded circular motion. You may be thinking, why am I telling you this here? Because many questions have been asked in the previous year, say for JEE exam, for the NEET exam, for the IIT Advanced. They rely upon some basic concepts. So this question, thus, since it covers ANET, AC and AT, I thought of including the concept explanation also. That's it. So that's the purpose behind this. So let us now discuss these 3: uniform circular motion, accelerated circular motion and retarded circular motion. And what in that we'll be discussing about ANET, AC and AT. How do we do that? We make use of a figure to understand the concept here. So we'll be discussing, let us contrast accelerated circular motion and retarded circular motion. So okay, let us also see what is uniform circular motion. See, when we have uniform circular motion, say this is the center of the circle. So this represents the direction of centripetal acceleration, and velocity is always tangential. So what I assume is the object is rotated in this direction, right, in the clockwise direction. So the velocity is like this, and the angle between centripetal acceleration and velocity is 90 degree. Now let us see what happens in the case of accelerated circular motion. So when we have accelerated circular motion, what happens is velocity velocity increases. So say if this is the center and we are considering this point here, so this will represent the direction of centripetal acceleration, and this here will represent the direction of velocity. And what we need to understand here is that this also will represent the direction of tangential acceleration, which means we have AC, we got AT, and therefore this will represent a net, and a net will make an angle theta with the velocity vector. And what is the speciality of this theta? This theta algebraically is acute in nature, right? Something which we will use again and again while solving problems, especially at the JEE mains level. Now let us see what happens in retarded motion. So when it comes to retarded circular motion, see, we got an object here executing circular motion in this direction. Okay, so let this be the center of the circle, and this is the point we are trying to consider here. So this represents the velocity vector, and velocity here is decreasing. This would represent the centripetal acceleration, and since the motion is retarded, so this what we have is retarded circular motion. Since the motion is retarded, what we can say is this will be the direction of tangential acceleration, right? And therefore the resultant acceleration or the net acceleration would be a net. Well, of course, to make such a line, a longer line will mean the magnitude of resultant is more. Let us not keep that. Okay, so this is the a net, and look at the angle made between theta. Look at the angle theta made between a net and velocity. That angle theta here is obtuse in nature. Okay, so uniform circular motion, no tangential velocity, only centripetal acceleration. Non-uniform circular motion, accelerated in nature, velocity and tangential acceleration are in the same direction. Angle made between the net acceleration and the velocity vector is acute. Circular motion, non-uniform circular motion, retarded circular motion, tangential acceleration is opposite to the velocity vector. Tangential acceleration, centripetal acceleration, the resultant is a net, which makes an angle theta with the velocity vector v, which is obtuse in nature. So that's the concept that we need to study with respect to this problem. Having said so, let's move on to the next question. If the vectors a and b are such that vector a plus vector b is equal to mode of vector a is equal to mode of vector b, then vector a minus vector may be equated to. So we know that if this is the given condition, then what is the value of cos theta? Cos theta is minus 1 by 2. And if cos theta is minus 1 by 2, how can we write modulus of vector a minus vector b as this will be equal to root of modulus of vector a plus vector b the whole square minus 4 mod a mod b cos theta, which is equal to root of. Now from the question we can say that mode of vector a plus vector b is equal to mode vector a. So this is mode of vector a the whole square minus, since it is given that mode of vector a is equal to mode of vector b, we can say that this is 4 times mode a into cos theta. So this is further equal to root of mode. Let us now say what is mode of vector a. So mode of vector a is a, which is its magnitude. So this will be a square minus 4a square into cos theta. So if we take out a square common, root of a square into 1 minus 4. What is cos theta? Cos theta is minus 1 by 2. So this becomes root of a square into, we got 1 plus minus 2 minus minus 2, so that becomes 1 plus 2 plus 3, and therefore root of modulus of vector a minus vector b is equal to root 3a, which gives us the correct option to be option D. Now what we'll do is we'll go through some of the basic results which are really important when it comes to certain values of theta, which are namely 0, 60, 90, 120 and 180. So what is the purpose of doing that? Because if you learn those formulas, you will tend to know that how did I arrive at this answer using a direct formula like this, and how did I directly write that cos theta is equal to minus 1 by 2. So that kind of inference will come from the results that we are going to discuss. And how will we do that? We will write down the results by first mentioning the resultant. So what is resultant? Formula for resultant. So resultant is equal to, or magnitude of resultant is equal to be more precise, magnitude of resultant is equal to a square plus b square plus 2ab into cos theta, right? Now let us say we need 4 cases. So we got case 1 when theta is equal to 0. So when I say theta is equal to 0, what does it mean? It means that we got 2 vectors here, which is vector A and vector B, and this theta represents the angle between them. So when we say it is theta is 0, what does it imply? It implies geographically that if this is vector A, then vector B might be something like this, right? The angle between them is 0. In which case, what is resultant? See, resultant here is R is root of a square plus b square plus 2ab into, what is cos theta? So when theta is equal to 0, what is cos theta? Cos theta is cos 0, which is equal to 1. So you get 2ab into 1. So what is R is equal to? R is equal to root of a square plus b square plus 2ab, or R is equal to root of a plus b the whole square, right? So what is R is equal to? R is equal to root of a plus b the whole square, which is a plus b. So this is one result we need, which means when theta is equal to 0, what is R is equal to? R is equal to a plus b. Now physically this means that when theta is equal to 0, the resultant vector will have a magnitude which is equal to the sum of magnitudes of the individual vectors. Now we need another case here, which is if A is equal to B, which means if we have 2 equal vectors under consideration, then what is R is equal to? R is equal to A plus A, which is equal to 2A. Okay, so this is case number 1. Alright, now let us discuss case number 2. So again, what is R is equal to? R is equal to root of a square plus b square plus 2ab into cos theta. And this time let us see case number 2 for which angle? Case number 2 for angle when theta is equal to 60 degree. And what is the value of cos theta? So when theta is equal to 60 degree, cos theta will be equal to, cos theta will be equal to cos 60, which is equal to 1 by 2. And when that is equal to 1 by 2, we have R is equal to root of a square plus b square plus 2ab into what is cos theta? Cos theta is 1 by 2. So what you get is root of a square plus b square plus ab. So we can write down the result as when theta is equal to 60 degree, what is r is equal to? R is root of a square plus b square plus ab. And when if a is equal to b, what do we have? We have r is equal to root of a square plus root of a square plus a square plus a square, which is root of 3a square, or which is root 3a, right? Okay, so we discussed two cases. One is theta is equal to 0, theta is equal to 60. Now let us discuss the same for, say, third case, case number 3. And this time theta is equal to 90 degree. So what would be cos 90? Cos 90 will be equal to sine 0, which is equal to 0. And what is r? R again is equal to root of plus times cos theta, which is equal to root of a square plus b square plus 2 into ab. What is the value of cos 90? Cos 90 is 0, so this terms get eliminated. So what do we get? So what we get is r is equal to root of a square plus b square. So when theta is equal to 90 degree, what is r is equal to? R is equal to root of a square plus b square. And if a is equal to b, what is r is equal to? R is equal to root of a square plus a square, and therefore r is equal to root of 2a square, which means r is equal to root of 2 times a. Okay. Let us discuss one more angle, which would be our case 4, which is when theta is equal to 120 degrees. So when theta is equal to 120 degree, what is cos theta? This is cos 120. So see, how do we calculate this? It's very simple. Don't go for the analytical method. Use only the algebraic method. So what is cos 120? Cos 120 is cos 90 plus 30, right? Now what is cos a plus b? It is cos a cos b minus sin a sin b. So no need to check for the quadrants and for the sine. If you understand this formula, you'll get the answer directly. Now, what is cos 90? We know that cos 90 is 0. So this will become minus. What is sin 90? Sin 90 is 1. What is sin 30? Is 1 by 2. So cos 120 is minus 1 by 2. So when theta is equal to 0, when theta is equal to 120, what is cos theta is equal to? Cos theta is equal to minus 1 by 2. Again, what is r is equal to? R is equal to root of a square plus b square plus 2ab cos theta. And what is r is equal to? Root of a square plus b square plus 2 into ab into what is cos theta? The value of cos theta is minus 1 by 2. So thus we get a simplified version as root of a square plus b square minus ab. So we can say when theta is equal to 120, what is r is equal to? R is equal to root of a square plus b square minus ab. And when we have a is equal to b, what do we get? We get r is equal to root of a square plus a square minus a square plus a square minus a square, which is r is equal to root of a square. Therefore r is equal to a. Let us do one more method. One more case, which is when theta is equal to 180 degrees. So if this is vector A, the other vector will be 180 degree opposite to it. This is vector B, vector A, vector B. So we know when it is cos theta is 180 degree. So for those people who really find the quadrants and the expansion difficult, please do like this. What is cos 180? You can do it. You can do this in many ways. Let us stick on to the very basic one. Cos 90 plus 90. So what is cos 90 plus 90? Cos A plus B is cos A cos B minus sin A sin B. What is cos A? What is cos 90? We know it is 0. What is cos 90? We know it is 0. What is sin 90? It is 1. What is sin 90? It is 1. So what do we get? Minus 1. Or other way around, you can also keep this formula close to you. What is cos n pi? Cos n pi is minus 1 the whole raised to n. So what do we have here? Instead of n, we have 1. So what is cos pi? Cos pi is minus 1 the whole raised to 1, which is equal to minus 1. Okay. So that's how you make things very simple. Now, what is again r is equal to? R is equal to root of a square plus b square plus 2ab into cos theta. Now we have r is equal to root of a square plus b square plus 2ab into what is cos theta? It is minus 1. So r is equal to root of a square plus b square minus 2ab. Therefore, r is equal to root of a minus b the whole square, which implies r is equal to a minus b. So when theta is equal to 180, r is equal to a minus b, and when a is equal to b, r is equal to 0. Okay. So these are the results which will definitely help you in doing problems later. So what I'll do is I'll write down these results as a table. So we have theta, we got expression for r, we have also got the expression when vector a is equal to vector b. So when theta is equal to 0, what is r? R is equal to the algebraic sum of a plus b, and here this becomes 2 times vector a. So we can say that r is equal to 2 times vector a. When theta is equal to 60 degree, when theta is equal to 0, when theta is equal to 0 degrees and when theta is equal to 60 degrees, so what we have is r is equal to root of, okay, wait, let me use some different colors so that it will be easy for you to take it down. So let's say we have theta, expression for r, and expression for r such that vector a is equal to vector b. All right. Now, when theta is equal to 0 degree, what is vector r is equal to? Vector r is equal to the algebraic sum, which is vector a plus vector b. And what is the condition when a is equal to b? This is r is equal to 2a. Similarly, when theta is equal to 60 degree, what is vector r is equal to? Well, I'm actually sorry. It is not vector r. It should be magnitude of r. Sorry. So r is equal to root of a square plus b square plus ab, and here r would be equal to root 3 times a. Now when theta is equal to 90 degrees, what is r is equal to? R is equal to root of a square plus b square, and similarly r here will be equal to root 2a. Now when theta is equal to 120 degree, what is r is equal to? R will be equal to root of a square plus b square minus ab. When a is equal to vector a is equal to vector b, what is r is equal to? R is equal to ab. And when theta is equal to 180 degrees, what is vector r is equal to? R is equal to the difference of magnitude. I'm so sorry that I'm writing the vector symbol everywhere. It should be magnitude of vector r. Or if you want to make it more correct, it should be magnitude of vector r. Okay, which is equal to a minus b. And what is r here? R here will be equal to 0. So if you just understand the primary logic here, when theta increases, right, r becomes, it moves from 2a to root 3a, then to root 2a, then to 1a, and eventually to 0. Okay, so that's the concept regarding this question. It was a lengthy solution because the intent was not to solve the question alone. The intent was to make sure that you solve any kind of these questions when you get, or maybe similar questions in a more faster way when you get the next time. Okay, so having said so, let's move on to the next question. Neat PYQ. An object is being thrown at a speed of 20 meters per second in a direction 45 degree above the An object is being thrown at a speed of 20 meters per second in a direction 45 degree above the horizontal. The time taken by the object to return to the same level is. See, we know that time of flight at 45 degree is equal to root 2 u by g, which means it will be root 2 by g into how much is the velocity? It is 20 meters per second. So 20 root 2 by g. D is the correct option. Now, if we try to solve this question otherwise and understand the importance of what's given to us. So basically, we've been asked to find out the direct application of this formula. T is equal to 2u sine theta upon g. But before we go any further, for those students who want to understand the concept well, let us discuss the idea in detail. So this is an object being projected at velocity u at an angle theta, right? From A, it reaches B, the maximum height. So P is the maximum height, and it comes to C, back to the flow. Now we know that when a body is projected with velocity u, it will at component at an angle theta, it will have two components. One will be ux and the other will be uy. I repeat, when an object is projected with velocity u at an angle theta with the horizontal, it will have two components of velocity, one being the horizontal component and the other being the vertical component, uy and ux. And from this triangle, what is ux is equal to? Ux is equal to u cos theta, and what is uy is equal to? Uy is equal to u sine theta. Now, what we need to understand is, we're going to apply the third equation of motion here, which is S is equal to ut plus half at square. Now, what we need to understand is that when we use S is equal to ut plus half at square, this S can be divided into two different components. One is along the x component and the other is along the y component. So S component S would be written as Sx and Y component Y would be written as Sy. Now, what do we mean by this? It means that at C, Sx is equal to AC and Sy is equal to 0. That is, displacement has two components, vertical component Sy and horizontal component Sx. As velocity has two components, Ux and Uy, displacement will also have two components, Sy and Sx. So what does Sy represent? Sy represents the displacement in the vertical direction and Sx represents the displacement in the horizontal direction. So when we say Sx at C, this was the initial position, this is the final position, which means AC is now the horizontal displacement. So displacement in the x direction, Sx is AC. Now what is y? Sy is the displacement in the vertical direction. When the object is at C, is there any vertical displacement? No. So if you draw a vertical axis here, at this point it has both vertical displacement as well as horizontal displacement. At this point it has both vertical displacement as well as horizontal displacement. But it comes here, the vertical displacement decreases, the horizontal displacement increases. At this point the vertical displacement becomes 0 and the horizontal displacement becomes the maximum, which what we call as range, right? But what we need to understand is, while applying this equation, if we write it as Sy, you need to convert every term into y component. So Sy is equal to Uy into t plus half into Ay into t square. Now, what is the vertical component of displacement when at C? At C, the vertical component of is 0. So this becomes 0 is equal to, what is Uy? Uy is u sine theta. And what is t? If here we denote as capital T, which is time of flight, plus half into, what is Ay? We know that Ay is minus g into t square. So what do we get? The expression for t is equal to 2u sine theta upon g. Okay, so that's about the time of flight. Now let us also discuss another point, which is, okay, let me write down the formula again. So we have time of flight, right? So we have time of flight, t is equal to 2u sine theta by g. Now what we need to understand a bit further here is, for the same velocity, for the same velocities, two bodies being projected at two different angles, theta 1 and theta 2, means if we have an object projected at u at angle theta 1, another object projected at same velocity but a different angle theta 2, if this is time of flight t1 and this is time of flight t2, then what we can say is t1 by t2 would be equal to 2u sine theta 1 by 2u sine theta 2, or in short, t1 by t2 will be equal to sine theta 1 by sine theta 2. Okay, so this is another thing that what we can keep in mind. Is there anything else that we could say? Yes. Additionally, what we can write is, we know time of flight t is equal to 2u sine theta by g. Now when is this applicable? When an object is projected with an velocity u with respect to the horizontal theta, right? In which case t is tu sine theta by g. Now what will happen if the object is projected with velocity u but not with respect to the horizontal? If it is projected with respect to the vertical as theta, and yet if the body goes through a projectile motion with time of flight t, what will time of flight be equal to? Will be equal to 2 into sine of by g, sine of the angle made by the horizontal, right? So what is the angle made by the horizontal? See, if this much angle is theta, what is the leftover angle? That would be 90 minus theta, right? So this much angle is 90 minus theta. So this here t will be equal to 2u sine 90 minus theta. Let us take t1 and t2 for our reference. So we have t1 and t2. Okay. Now let us find the ratio between t1 and t2. So what is t1 by t2? T1 by t2 will be equal to 2u sine theta by g times g by 2u sine 90 minus theta, right? Which is further equal to t1 by t2 is equal to g and g by is 1, 2u by 2 is 1, sine theta by what is sine 90 minus theta? Sine 90 minus theta is cos theta. So what we get is t1 by t2 is equal to sine theta by cos theta. Therefore t1 by t2 is equal to tan theta. Is a very important result that may be required while solving problems at the next level. Okay, is there anything that we could add? We discussed about theta, we discussed about, okay, let us now discuss one more thing regarding the formula. So what is t is equal to? T is equal to 2u sine theta by g. Now for a constant angle of projection, theta, t is equal to 2u sine theta by g. What I mean is when I say constant angle of projection beta, what with u varies, which means I'll fire the object with u at an angle theta. In the second case, I'll fire the object with 2u at an angle theta. In the third case, I'll fire the object with 3u at an angle theta. So what remains constant? Angle of projection theta, constants. But what varies? U varies. U, 2u, 3u. In which case t is proportional to 2 by g into sine theta into u, not proportional to. So t is equal to 2 by g into sine theta into g, 2 by g into sine theta. Now g is a constant, 2 is a constant. If theta is a constant, sine theta will also be a constant. So which means we have t is equal to constant into a constant is a constant. That constant divided by constant will be another constant. So we have t is equal to k into u, or in other words, t is proportional to u. When t is proportional to u, let us say if this was t, and if in this case, if the time of flight is t dash, right, what will, so we can write here that t is proportional to u, and what is t dash? T dash will be proportional to 2u, in which case if you take t by t dash, what do you get? U by 2u, or in other words, you get, oh, it's not t1, it's t dash, right? Okay, either way, so t dash is 2t, or generally we can write that in general t dash will be equal to n times t. So I think these are the minimum variations that you should be knowing. Okay. Oh, was one another important thing, which is with respect to the angle. So T is equal to, again, what is T is equal to? 2u sine theta by g. So we'll discuss three cases when theta is equal to theta is equal to theta is equal to. So let us say when theta is equal to 30 degree, theta is equal to 45 degree, and theta is equal to 90 degree. So when theta is equal to 30 degree, what is T is equal to? 2u into sine 30 by g. T is equal to 2u into sine 45 by g. T is equal to 2u into sine 90 by g. So we have T is equal to, what is sine 30? 1 by 2. So this will become 2u into 1 by 2 the whole upon g, which is equal to u upon g, right? Because 2 by 2 is 1. And here what we get is 2u into 1 by root 2 the whole upon g. So this is root 2 u by g. And for 90, what we get is, what is sine 90? Sine 90 is 1. So what we get is 2u by g. So we got u by g, root 2 u by g, and 2u by g. And for ease of calculation, we may, if g is assumed to be 10 meter per second square, then we can assume that t is equal to u by 10 at t is equal to 30 degree, and at t at 90 degree it is u by 5. Why u by 5? Because 2u by 10, right? So that becomes u by 5. So these two formulas can also help you in saving your time while doing problems with more number of steps. What is that? Time of flight at 30 degrees, velocity divided by 10. Time of flight at 45, 90 degree is initial velocity divided by 5. Okay, so that's it with this question based on time of flight. Let us do the next question from NEET previous year. The horizontal range and maximum height of a projectile are equal. The angle of projection of the projectile is. See, this is a very straightforward question, and we know that theta is equal to tan inverse 4 by n, and since it is said that both of them are equal, n is equal to 1, therefore the correct answer would be theta is equal to tan inverse 4, which means wait, okay, yeah. So we have option B to be the correct answer. But I would actually suggest that we go somewhat more deeper into the subject to have a better understanding about what we are trying to learn. So say this is the ground. An object is projected with velocity u at an angle theta. It attains the maximum height at point P. It attains the maximum height at point P, and it completes the maximum distance at C. So we have AC as the range and PR as the height. So we know that we have derived this. And what is the equation for H is equal to? H is equal to u square sine square theta by u square sine square theta by 2g. And what is R is equal to? R is equal to u square sine 2 theta by g. And when we say that according to the question, the height of a projectile and range are equal, when we say that height is equal to range, what do we get? U square sine square theta by 2g is equal to u square sine 2 theta by g. So u square by u square is 1, g by g is 1. So what we get is sine square theta by 2 is equal to, what is sine 2 theta? It is 2 sine theta cos theta, which means, so we have sine theta into sine theta is equal to 4 times sine theta cos theta. Sine theta by sine theta is 1. So what we get is tan theta is equal to 4, right? Now, this was the basic understanding what we should be having regarding this equation here. Let us do one more extension of the same topic, which will actually help you, which it goes like this. Okay, so when we say tan theta is equal to 4, what we need to understand is theta is equal to tan inverse 4, and this value, it comes somewhere around 75 degree. Well, it's actually 75 degree and 58 minutes. Okay, so we have otherwise learned that when theta is equal to 45, right? When theta is equal to 45, what is the relationship between h and r? It is that 4h is equal to r, right? So we have two values, 4h is equal to r and h is equal to r. So h is equal to r when theta is equal to 75 degree 58 minutes, and when theta is 45, we have 4h is equal to r. Now there is one important relationship, that is r is equal to 4 times root of h1 h2, the derivation of which I would say is really important. Well, not the process of derivation, but if to understand what that is. So what we have here is an object which is projected at an angle theta with velocity u, another object projected at an velocity u at an angle, say at an angle 90 minus theta. Oh, diagrammatically doesn't make sense, sorry for that. So what we have here is an object which comes up like this, same maximum height h1, and another object which comes like this, with height, maximum height h2, but what remains constant is the range covered by these two bodies. Okay, so what are we talking about here? We're talking about two bodies projected with the same velocity, having the same range, but having different maximum heights, and different maximum heights and angles at theta and 90 minus theta respectively. Okay, so now we'll analyze these two motions. So what is the maximum height here? h1 is equal to, h1 we know that is equal to u square sine square theta, say theta by 2g, right? And what is h2 is equal to? h2 will be equal to u square sine square, what is the value of theta here? It is sine square 90 minus theta the whole upon 2g, right? Now, what is the meaning of h1 into h2 is equal to? So h1 into h2 is equal to u square sine square theta by 2g into u square sine square 90 minus theta the whole upon 2g. Now what we'll do is we'll try to make this equation more sensible. So okay, let us first write down the next second term. So we have u square sine square theta by 2g into, see, what is sine 90 minus theta? Now, please, I have a request that if you find um, learning these trigonometric identities as difficult while assigning the quadrants and angles, the symbols of it, make sure you learn like this way. It will really help you. I think it should be helping you. So what is sine A minus B? Sine A minus B is sine A cos B minus cos A sine B. So what is A here? 90. What is B here? It is theta. So what is sine A? It is sine 90 cos theta minus second term is cos A, which is cos 90. Sine B is sine theta. What is cos 90? See, sine 0 is equal to cos 90 is equal to 0. So this term is 0. This complete term is 0. So all what we have is sine 90. What is the value of sine 90? See, cos 0 is equal to sine 90 is equal to 1. So this becomes 1 into cos theta, which is equal to theta. So which is equal to cos theta. So what is sine 90 minus theta is equal to? It is equal to cos theta. So instead of u square sine square theta, u square sine square 90 minus theta, what can we write here? U square cos square theta. Okay. Having said so, what I'll do is I'll make another rearrangement here. So I'll write it like this: u square. Now sine square theta, I'll write it as sine theta into sine theta, the whole upon 2g into into g into u square into cos square theta. I'll write it as cos theta into cos theta, the whole upon. Okay, so let me use a different color itself so things will become clear. So we have u square cos theta, the whole upon g, and that 1 by 2, I'll write it over here. Okay. Now if we go further, what do we get? What we get is this is equal to half into 1 by 2 into. Now I'll make some rearrangements here. U square by g into sine theta into, I'll bring 1 cos theta over here. This becomes into cos theta into u square by g into cos theta into, I'll bring the other sine theta here, sine theta. Okay. And we'll do one more addition, which is multiplying 2 on the numerator as well as the denominator. Multiplying another 2 on the numerator as well as the denominator. Okay. Now, what is sine 2 theta is equal to? Sine 2 theta is equal to 2 sine theta cos theta. In which case, this is equal to half into 1 by 2 into u square sine 2 theta by u square sine 2 theta by g into, this will become u square sine 2 theta by g, right? So what do we get? 1 by 2 into 1 by 2 is 1 by 4. Oh, we have into 1 by 2 here. I'm sorry, I skipped that part. It's 1 by 2 into 1 by 2. So 2 into 2, 4 into 2, 8 into 2 is 16. So what we get is 1 by 16 into, what is u square sine square 2 theta by g? It is r, right? It is r. What is u square sine 2 theta by g? It is also r. Basically, it is r2 and r1, but we know from the explanation that both the ranges are equal. So it is basically equal to say that r1 is equal to r2, right? So this reduces to 1 by 16 r into r, which is equal to 1 by 16 into r square. Now, what is the LHS? The LHS is h1 into h2. So we have got h1 into h2 is equal to 1 by 16 r square. So What is r square is equal to? R square is equal to 16 into h1 h2, and what is r is equal to? R is equal to root of 16 into h1 h2, and therefore r is equal to 4 h1 h2 raised to 1 by 2, or let us write it much more. So r is equal to 4 into root of h1 h2, right? And if we try to understand this as a table, we have got theta and relationship between h and r. So when theta is equal to 75 degrees and 58 minutes, what we get is h is equal to r. When theta is 45 degrees, what we get is 4h is equal to r. And when the two projectiles are fired at theta and 90 minus theta, what is the relationship between them? We have r is equal to 4 into root of h1 h2. So this table can also be useful if you solve problems. Maybe if you get a question which is based on either h is equal to r or 4 is equal to r, you don't need to derive further. You can just directly solve the question by using these angles, or vice versa. Okay, so now let's move on to the next question. Let r1 be 3ti plus 4t square j, and r2 be 4t square I plus 3tj, where they represent the position of particles 1 and 2 as a function of time t. Find the relative speed of the two particles at instant. That's actually the question. Is at instant t is equal to 1. So let us first write down what's given to us. So we have r1 is equal to 3t I cap plus 4t square j cap. And what is r2 is equal to? R2 is equal to 4t square I cap plus 3t j cap. In which case, what is V1? V1 will be equal to d by dt of R1, which is equal to d by dt of 3ti plus d by dt of, see, if you do it actually quickly, it goes like this. 3 plus 80 is V1. V2 will be 80 plus 3, right? So what is V2 minus V1? It will give you 5t minus 5t. So modulus of V2 minus will be equal to root of 5 square plus 5 square, which is root of 2 into 5 square, which will give you 5 root 2 as the correct answer. So that's how you'll approach the question during an examination. But I was just trying to make sure that the explanation is correct and explanation is detailed as well. Okay, right. So it's d by dt of 4t square to j cap. So what we get is derivative of 3ti is 3i, 4t square is 8t j cap. Similarly, what is V2? d by dt of R2, which is equal to 80 into I cap plus 3 into j cap, right? So we got V1 and we got V2. Now, what is V12? It is velocity of 1 with respect to 2, or it is velocity of 1 as seen from 2. So V12 is V1 minus V2, which is 3i cap plus 8tj minus 8ti plus 3j, which will further be equal to 3i plus 8tj minus 8ti cap minus 3j cap. Now I'll bring the I components together, right, and the j component together. So what do we get? Three I cap minus 8t I cap plus 8t j cap minus 3 j cap. So what is 3i cap minus 8i j cap? 3i minus 8ti. Okay, we can't find that value, right? So what we need to do is this is v12. Now we need to substitute v12 at t is equal to 1. So what do we get? We get 3i cap minus t is 1 here, 8 into 1 I cap plus 8 into what is t? T is 1, so this becomes 1 into j cap minus 3 j cap. So v12 again is 3i minus 8i plus 8j minus 3j. So v12 is minus 5i plus 5j. And what is therefore modulus of v12? Modulus of v12 will be root of minus 5 square, which is 5 square plus 5 square, which is 5 root 2, which gives us the option as option C. Yes. Okay. So if we know just one concept out of this, we know that throughout the projectile motion, right? Throughout the projectile motion, the x component of initial velocity remains constant. So if you assume that this is u and this is ux and uy, ux will remain constant throughout the motion. So this will be ux, 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 and even when the object reaches the ground, the horizontal component will be excuse me, horizontal component would be ux. So there is no change in the horizontal component, that is ux. But what varies is uy. Now, the moment you say that ux remains constant, that option which has negative ux is the wrong option, right? So the only possible options are C and D. Now, if you look at C, it says the same velocity as that of A. So if that was the case, here the velocity would look like this, u, and the object should be going like this, which is not the case. So the object is actually coming down, in which case the resultant velocity should be acting downwards, which means the velocity here is actually minus 3j, and that's how we get the resultant velocity acting like this. Therefore the body will come downwards. Okay, so this is the most simplest explanation for this, the logical one. Let us now look at the numerical part of this, or let us say the analytical explanation for the same. Let us prove what all things we said now as statement, let us prove them logically. I'm sorry, let us prove them arithmetically. So say we have the ground here, point of projection is A, it reaches C, it is projected with velocity u at an angle theta. The moment I say this, I know this component would be u cos theta, and this component would be u sine theta. The object goes through a projectile path, it lands here at C, and at C we have two different components again, which is u cos theta and u sine theta in the opposite direction, and we know that resultant velocity v acts here, right? So okay, I think if we write it like this, then we assume that all things are correct. Let us write down only the component. So this is ux and this component here is uy. So this is the initial part of the motion. So when we arrive at the final part of the motion, what we get is this horizontal velocity would be vx, and the vertical velocity here would be vy, and the resultant velocity would be v. Now we know that the final velocity v has two components, which is vx, vy as well. Now what is vx is equal to? See, vx is equal to ux plus ax into t. Similarly, what is vy is equal to? Vy is equal to uy plus ay into t. Now we know that ax is equal to 0. Why? Because there is no horizontal acceleration. And we also know that ay is negative acceleration due to gravity. Ay is minus g, which means vx is equal to ux. So when we say vx is equal to ux, in the final position, what is the vx here? Vx here would be equal to ux. Therefore, we can say that vx, that is the x component of final velocity, is equal to ux, which is x component of initial velocity, which is equal to u cos theta. Right? Now let us find out the case with vy. See, when we go for vy, we can write that vy is equal to uy plus, instead of ay, we can write it as minus g into t. Right? Now, what is uy? Uy, we know it is u sine theta. So this becomes plus minus g into instead of t. See, what we need to understand is the object was in initial position at A. When it completed the motion, it is in the final position now. So it has completed the motion, and when it has completed the motion, what does t stands for? T stands for the time of flight, because this is a projectile motion, right? So t stands for the time of flight. So instead of t, I can write here time of flight. Now, since it is time of flight, we can write that vy is equal to u sine theta plus minus g into, what is time of flight equation? We have it as 2u sine theta upon g. Therefore, what is vy is equal to? G by g is 1. So what we get is u sine theta minus 2u sine theta, which gives us that vy is equal to minus u sine theta, or we can write that vy is equal to minus u. What is u sine theta? See, u sine theta, we have written it here. What is u sine theta? It is uy. So vy is equal to minus uy. What does it mean? It means that the y component of final velocity is equal to negative of y component of the initial velocity. Apply this logic here. What do we get? Y component of the final velocity is equal to negative of, right? Negative of y component of the initial velocity. What is the initial velocity in the y component? It is 3j. So what we get is 3j. So y final will be equal to minus 3j, and we know that vx is equal to ux. So what is ux? According to the question is 2i. So we have that correct option where 2i and minus 3j there, which is option D again. Okay, so that would be another explanation for the same. Now, one question that may come into your mind is, how do you say that this angle is also theta? It should make sense mathematical and logical as well. So let us try to understand the mathematical part of it. So suppose this is the diagram we use for the reference, same diagram, and we know the equation that tan beta, where actually, okay, I think it's better we draw another diagram. Let us say a body is projected from A, right? From A with velocity u at an angle theta, right? Now this component is u cos theta. This component here is u sine theta, and we assume that at this point the body is coming down here with velocity, final velocity v, where this is okay, where this angle is what we call as beta. Okay, so we know by equation that at any point in the trajectory of the projectile, we can say that tan beta is equal to, the equation is u sine theta minus gt the whole upon u cos theta. But again, for the motion from A to B, what is t is equal to? T is equal to time of flight. And what is the equation for time of flight? It is 2u sine theta by g. In which case we can write here that tan beta is equal to u sine theta minus g into, what is the value of t? It is 2u sine theta upon g the whole upon u cos theta. So now g by g is 1. U sine theta minus 2u sine theta is minus u sine theta. So we have minus u sine theta by u cos theta. Therefore, tan beta is equal to minus u by u is 1 minus tan theta, which means beta is equal to minus theta. Otherwise, it explains that if an object is projected at an angle theta, it will hit the ground. It will hit the ground at an angle minus theta, which also explains our claim that if Vx is equal to Ux, then Vy should be minus Vy, because it is this component that acts downwards, right? So now if we draw the diagram here at B, this is Vx and this is Vy. Okay, so that's the explanation with this question. I think almost all of the concepts are explained. No need to go any further in this specific problem. Having said so, let's start the next question. At an instant, the coordinates of a particle x is equal to at square, and y is equal to bt square, and z is equal to 0. The magnitude of velocity of the particle at an instant is, okay, a very simple question. So x is equal to at square, y is equal to bt square, and z is equal to 0. So what is Vx is equal to? Vx is equal to d by dt of x, which is 280. What is Vy is equal to? D by dt of y, which is equal to 2bt. And what is Vz? It is 0. So in short, Vx is equal to 280 and Vy is equal to 2bt, in which case what is V is equal to? Root of Vx square plus Vy square, ideally plus Vz square, which is equal to root of 2at the whole square plus 2bt the whole square, which is equal to root of 4a square t square plus 4b square t square, which is further equal to, if I take 4t square common, what do I get? Into a square plus b square, which is root of 4t square into root of a square plus b square, which is equal to 2t into root of a square plus b square. A very straightforward, a simple question, which gives us the correct option as option D. I don't think such questions are asked in NEET exam, is it? Oh, right, this is not for NEET exam. Yeah, that's why. Okay, anyways, see, while you prepare for the NEET exam or for the JEE exam, please make sure that you don't underestimate simple questions. Simple questions are the one which gives you conceptual understandings for the the questions at the higher level. Okay, that's having said so. Let's move on to the next question. A particle is moving such that its position coordinates x, y are 2, 3 at t is equal to 0, 6, 7 at t is equal to 2, 13, 14 at t is equal to 5. The average velocity from t is equal to 0 to t is equal to 5 is. Okay. So if we understand it in a coordinate axis, x-axis, y-axis, the initial point is a 2, 3. So somewhere over here, or let's say somewhere over here. So a is 2, 3. And the final point is 13, 4. Say somewhere over here, which is P is 13, not 4, 13, 14. Which means the displacement is AB, right? Displacement is AB. So for the exam point of view, I would do it like this. AB is the displacement, right? AB is the displacement. So AB is the total displacement, which will be equal to root of, by using distance formula. By using distance formula, what is distance formula? Root of x2 minus x1 the whole square plus y2 minus y1 the whole square. We have x1 y1 and x2 y2. So what we get is root of 13 minus 2 the whole square, 13 minus 2 the whole square plus root of 14 minus 3 the whole square, which is equal to root of 11 square plus 11 square. And what is the total time? Time is t is equal to 0 to 5, which is 5 seconds. Therefore, the answer should have 11, 11 and 5. So we have 11 by 5 into 1 by 1, because this is 11i plus 11j by 5. So I think we did it in less than 2 minutes. So the examination hall, it should be definitely less than 1 minute. So that will be the logic while solving the question in the examination hall. Now, let us try to understand it in the pure vector method, right? So what we have here is say we have a coordinate axis again, y-axis, x-axis. So this is origin, and let us say this is the first point, right, which is 2, 3. So now when there is a position, there should be a position vector, right, which I'll call it as vector OA. Now what is vector OA is equal to? Vector OA is equal to 2i cap plus 3j cap. Now what is the final position B? So we have another vector OB, and the position of B is 13, 14. So we have vector OB is 13i cap plus 14j cap. And what is V average is equal to? V average is equal to the total displacement by the total time, or okay, that would be the analytical method. If we write it like this, so we have vector V average would be equal to vector AB upon total time, which is 5 seconds, right? Now, see, this is where the concept of vector comes into picture. So this is vector AB, right? So we have vector AB like this. We have vector OA and we have vector OB. So from triangle of vector addition, how can we write this as? We can write this as vector AB, right? Vector AB plus, oh, I'm sorry. It should be written as, this is the common tail. Yeah, so we can write it as vector OA plus vector AB is equal to vector OB. In other words, what is vector AB? Vector AB is vector OB minus vector OA. So what is vector AB? Vector OB vector. So we have vector OB minus vector OA, the whole upon 5 seconds. Now, if we do this, the vector addition, what do you get? What is vector OB? Vector OB is 13 I cap plus 14 J cap minus, what is vector OA? It is minus 2 I cap minus 3 J cap, the whole upon 5. So if you bring out the I components together, what do you get? 13 minus 2I, which is 11 I cap plus 14 minus 3 is 11 J cap, the whole upon 5. So this is the V average vector. So this will be the pure, the vector approach behind this question. You can do it other ways also. So yes, a very not that simple question when it comes to solving it in a subjective fashion, but when objective question, I think this is a very straightforward one. You just need to apply the formula and get into the option directly. So now let's move on to another question, which I think is from NEET. A projectile is fired from the surface of the earth with the velocity of 5 meter per second and theta with the horizontal. Okay, so we have fired at 5 meter per second, angle theta, completes the projectile. Another projectile is fired from another planet. The moment we say another planet, what should we understand? That GE is equal to 9.8 and G of another planet, it may or may not be equal to the acceleration due to gravity on Earth. So considering another planet, it is launched at 3 meter per second with the same angle theta, completing the projectile. But here let us take this as G1 and this as G2. Okay, so we know that when we have a identical trajectory, what is the equation that we are going to use? It is very simple, and it is G by U square is equal to a constant, which means G1 by U1 square will be equal to G2 by U2 square. What is G1? Given to be 9.8. What is U1? It is given to be 5. So 5 square is equal to, what is G2? Is that we need to find out G2. What is U2? It is 3 square. So what is G2 is equal to? G2 is equal to 9.8 into 3 square is 9 upon 25. For the ease of calculation, I'm going to consider 9.8 roughly equal to 10. Okay, so we get 10 into 9 by 25. 5 5s are 25, 5 2s are 10. So this is 18 by 5, 5 3s are 15, 18 minus 15 is 3, 30, 3.6, close to 3.6 is their option. Oh yeah, yes. So we have an option A, 3.5. So again, it took me 2 minutes. I drew the diagrams and I wrote the entire formula. While you practice in the examination hall, it should just take less than 1 minute, because if you know this formula, it's just direct substitution, right? But now let us see, how did we arrive at this formula? So we know that the trajectory of projectile motion is given by the equation y is equal to x tan theta minus gx square by 2 u square cos square theta. Now we need to apply y in two cases, y1 and y2, where y1 is on Earth and y2 is on some other planet. But we've been given that the trajectory is identical, which means y1 is equal to y2 is what we have. Now what is y1? y1 is x tan theta minus gx square the whole upon 2u square cos square theta. So for the ease of understanding, let us take theta 1, tan theta 1. Now what is this equal to? This is equal to x tan theta 2 minus gx square the whole upon 2. So this should be u1 square, right? Yeah, 2u1 square and then 2u2 square into cos square theta 2. Now since both of them are launched at the same angle, we can say that theta 1 is equal to theta 2. Therefore tan theta 1 should be equal to tan theta 2. Therefore cos theta 1 should be equal to cos theta 2, which means x tan theta 1 is equal to x tan theta 2. Those two terms will get cancelled. So what else do we have? Minus gx square by 2 u1 square cos square theta 1 is equal to minus gx square by 2 u2 square cos square theta 2. Now if you see, cos square theta 1 and cos square theta 2 are the same. X square by x square is 1. So all what we are left is g by, in which case I should ideally be writing g1 and g2, right? g1 and g2. So we have g1 by u1 square is equal to g2 by u2 square. So this is how we arrive at the formula in a very algebraic manner. Okay, so yeah, okay, so that's it. So let's move on to the next question. The unit vector perpendicular to each of the vectors 3i plus j plus 2k and 2i minus 2j plus k. So if we solve it in the examination hall, how will you do this? You'll write it as I, j, k. Then we have 3, 1 and 2, right? And we have 2, minus 2 and 1. If we open this, I will have these two. So I into 1 into 1 is 1, 2 into minus 2 is, 2 into minus 2 is minus 4. So it is 1 minus minus 4 is 1 plus 4, right? 1 plus 4 minus j into, so while we do j, we get 3 into 1 is 3, 2 into 2 is 4, so 3 minus 4 is minus 1, right? Plus k into 3 into minus 2 is minus 6, 2 into 1 is 2, 6 minus 2 is minus 8. So what we get is 5i plus j minus 8k. So this is the vector that we're looking for, and there's only one option with 5i plus j minus 8k. That gives the correct answer. It's less than 1 minute to do this question. But please don't stop here, because what happens is, if we calculate the magnitude, some of the okay, so 5 by, there is no probability that any of the terms will get cancelled here. So the only possible option, and in fact the correct option, is 5 plus 8j minus k. And what is the magnitude? The magnitude will be root of 5 square plus 1 square plus 8 square, which is root of 25 plus 1 plus 64, which is root 25, 6, 30, 26, 60, 90, which is actually 3 root 10, right? Okay. So since we found a 3 root 10, and the answer is now that we have the answer, I would suggest, let us try to look what the question is actually about. See, this is actually a very beautiful question, because it is not the answer that's beautiful, but the demand of the question that makes the question really beautiful. Because the question is not to find out the unit vector perpendicular. The question is actually asking you to define cross product. And how is that? Because we know that by definition, cross product of two vectors, say for example, cross product of two vectors, vector A and vector B, is another vector. Cross product of two vector is another vector, vector C, which is perpendicular to both, vector A and vector B. So when the question asked about unit vector perpendicular to each of the vectors, it was actually asking you to find out the cross product. Now let us just spend a couple of minutes to actually understand what this unit what is the concept of cross product that we're actually talking about. See, when we have vector, let us take an inclined. Say for example, if this is vector A, okay, if this represents vector A and if this represents vector P, then what is the cross product? It is another vector like this, right, which is perpendicular to both these vectors. So this vector C, is what we call as vector A cross vector B. Now another thing what we need to understand is, say, and how do we make an okay, let's say one more thing, and we'll be done with it. Let's say we have vector A here, right, vector A, and say, okay, let us take this vector B. So this is vector B, this is vector A. Now say, what is this? This is A cross B. Well, actually this represents A cross B, the direction of A cross B, and we know that this vector is perpendicular to both the vectors A and B. Now what is the magnitude of this A cross B? See, that is obtained by drawing a parallelogram using the other two vectors, vector A and vector B. Okay, so if the angle between vector A and vector B is theta, then this parallelogram completed by joining the vectors containing this angle theta is the magnitude of vector A cross vector B. So it means that this shaded region, the area of it will actually represent the magnitude of A cross B, and it is this magnitude that we calculate algebraically using the method of determinants. Okay, so that is one more thing about cross product. Okay, one final thing and then we are done. So let's say this is vector P This is vector A. Now, what is this? This is vector A cross vector B, and we often see this in the in the definition of cross product. We see a unit vector. So this is that unit vector n cap along the direction of vector A cross vector B, and we can also have another vector here. Can you guess what would that be? This vector is what we call as vector B cross A, or this can also be expressed as minus A cross B. Okay, so this is it about cross product and the analysis of it. So always keep this in mind. Two vectors in a plane, right? In a plane, another vector perpendicular to this plane in such a way that the vector is perpendicular to both the given vectors. It represents the direction, unit vector along that direction, and opposite to that, what we get as B cross A. So A cross B, A B in the reverse direction, B cross A, right? Okay, so and always try to visualize this in 3D. See, all of this basically takes place in the three-dimensional axis. That's how it if you can visualize these things in 3D, you'll understand the concept of A cross B or cross product better. So is there anything else we should add here? Maybe when we see another question. So let's now move on to the next question. A particle is moving on a circular path of 10-meter radius. At any instant of time, its speed is 5 meter per second. So v is given to be 5 meter per second as a rate of 2 meter per second square. So tangential acceleration is given to us as 2 meter per second square. Since everything is in every given unit is in meter per second, we don't need to convert to meter. So what is AC? AC we know is v square by r. What is v? 5 square. What is r? 10 meter. So we get 25 by 10, which is 2.5. So we can write that A net is equal to root of AT square plus AC square, which is equal to root of 2 square plus 2.5 the whole square, right? So okay, so it's 2.5. That becomes okay. Let's assume this approximate this to be 3. So what do we get? Root of 4 plus 3 square is 9. So it is root 13, right? Root 13. 3 square is 9. 4 square is 16. So the value should be definitely between 3 and 4. So it can't be 5, it can't be 2, it can't be 4. The only option we have is 3.2. Or if you want, if you have enough of time and if you have much confidence in your numerical skills, then you can solve like this. 4 plus 2.5 square is 6.25, which is root of 10.25, and then you can find out the root by the algebraic method. But see, while you are solving an examination, while solving such a question in a paper, the fundamental aim is to get the correct answer logically. Of course, logically. I mean, it's not on a random guess. So we solve it in a pure logical way. So yeah, so that's it about this question. And for those people who haven't gone through the previous lecture on difference between uniform circular motion, accelerated circular motion, and retarded circular motion, let me give you a quick glimpse of it. Not much as detailed as we had discussed in the previous problem. Wait, was it in this? Yeah, it was in this chapter itself. So we have uniform circular motion, accelerated circular motion, and retarded circular motion, right? So in uniform circular motion, there is only centripetal acceleration and tangential acceleration is 0. In accelerated circular motion, right? In accelerated circular motion, what we have is centripetal acceleration acting downwards, velocity not downwards, towards the center, velocity acting at the tangential, and another vector which is the tangential acceleration acting at the same direction of velocity. And then we have a net. And what is the angle here? Angle made between v net and theta. Angle made between v net and theta is, the nature of it is acute. Now what we have, another version is centripetal acceleration acting inwards, right? Velocity acting outwards, and since it is decelerated motion, tangential acceleration in the opposite direction. So this is retarded circular motion. And where will be a net? A net will be acting over here like this. This will be a net. So angle made between velocity vector and a net here is theta, and this theta is obtuse in nature. So always keep this in mind, because there may be questions coming up directly to answer about directly to comment upon the angle made between a net and velocity vector, in which accelerated circular motion is acute, and in case of retarded circular motion, angle between velocity vector and net acceleration is obtuse. If vectors a is equal to cos omega t and sin omega t, and b is equal to cos omega t and sin omega t by 2 and sin omega 2 by 2 are functions of time, then the value of t at which they are orthogonal. Okay. So when they are orthogonal, what do we know? That a dot b is equal to 0. Now what is a dot b? A dot b is cos omega t by 2 plus sin omega t by 2, and this is equal to 0. Now this is of the form cos a cos b plus sin a sin b. Now what is cos a cos b plus sin a sin b? It is trigonometric expansion of cos a minus b, which means we have cos of, instead of a we have omega t, instead of a we have omega t, and instead of b we have omega t by 2. So a minus b will imply omega t minus omega t by 2 is equal to 0, and instead of 0 we'll write cos 90, right? Because cos 90 is 0. So if this is the case, then we can take cos inverse on both sides. So what do you get? What is cos inverse cos theta? Cos inverse cos theta is equal to theta. So what we get here is omega t minus omega t by 2 is equal to pi by 2. So omega t minus omega t by 2 is 1 minus 1 by 2 is, which is 1 by 2. So we have omega t by 2 is equal to pi by 2. 2 by 2 is 1, and therefore t is equal to pi by omega. And okay, that means the correct option is option D. The position vector of a particle r is given as a function of time as r is equal to 4 sine 2 pi t. So we will be given that r is equal to 4 sine 2 pi t I cap plus 4 cos 2 pi t j cap. So if we are doing this in the examination hall, we should be doing like this. We have velocity vector is equal to 4 cos 2 pi t into 2 pi plus 4 into minus sine 2 pi t into 2 pi. So v will be equal to 8 pi cos 2 pi t minus 8 pi sine 2 pi t. Therefore magnitude of velocity will be equal to root of 8 pi square, sorry, root of will be equal to 8 square pi square, and therefore velocity will be equal to 8 pi. Right, this is how we do this. Yes, we did it in less than one minute. When I say less than 1 minute, of course I do take down, because we are writing so much, and in the examination hall you will even write less than this, right? So in which case the magnitude is 8 pi, and therefore this statement is wrong. It is not 8 meter per second, it is 8 pi meter per second. Now let us try to understand the other options also, because you may ask, what if we don't find velocity? See, that you don't have that luxury of not finding velocity here, because the question says path, acceleration and velocity, magnitude explicitly, so we will have to find the magnitude of velocity no matter what. Anyway, uh, let us now try to understand the question in detail. Let us try to explore each and every option. Okay, so what is given to us? R is equal to 4 sine 2 pi t I cap plus 4 cos 2 pi t j cap, right? In which case, what is x component of r here? It is equal to 4 sine 2 pi t. And what is x component of y here? It is equal to 4 cos 2 pi t, right? And when you add these two, what do you get? X square plus y square is equal to 4 square sine square 2 pi t plus 4 square cos square 2 pi t, and therefore x square plus y square is 4 square into, now we can take 4 square common, so what we get is sine square t 2 pi t plus cos square 2 pi t. Therefore x square plus y square is equal to 4 square into, what is sine square theta plus cos square theta? It is 1. So we have the equation x square plus y square is equal to 4. Now when we say x square plus y square is equal to 4, we can also write it like this: x minus 0 the whole square plus y minus 0 the whole square is equal to 4 square. And if you compare this with the standard equation of a circle, we have x minus a the whole square plus y minus b the whole square is equal to r square, which means by comparison a is equal to 0, b is equal to 0 and r is equal to 4, which means the given displacement is actually a circle with center 0, 0 and radius 4, which makes our first option correct, right? Now let us see the second option, which is about acceleration and velocity. So again, what is r is equal to? R is given to be 4 sine 2 pi by 2 I cap plus 4 cos 2 pi t into j cap. See, what I'm going to do is I'm going to write every step, okay, and break down every step, because so some of you may feel that I'm going too basic, because see, because this video, what I believe is they should help even a person who is trying to solve it for the first time. He should be able to solve it in detail. Okay, so I'm going to make it break down to multiple steps, so please don't feel offended by that. So if we differentiate this, what we get is 4 into d by dt of sine 2 pi t, and always understand, when you differentiate, you need to differentiate the angle also, so into d by dt of 2 pi t I cap, right, plus the same story for the second term also, 4 into d by dt of cos 2 pi t into d by dt of 2 pi t, right? So what do we get? Sorry, this is not r, this is v, right? So what is v is equal to? V will be equal to 4 into, what is derivative of sine 2 pi t? It is cos 2 pi t. What is derivative of 2 pi t? It is 2 pi into I cap plus 4 into, what is the derivative of cos 2 pi t? Minus sine 2 pi t into derivative of 2 pi t is 2 pi, right? So eventually what we get is velocity vector v is equal to 8 pi into I cap, 8 pi cos 2 pi t into I cap minus 8 pi sine 2 pi t into j cap, right? And what is magnitude of velocity vector? That would be equal to root of 8 pi the whole square cos square 2 pi by 2 pi t plus 8 pi the square sine square 2 pi t, and therefore vector v is equal to root of 8 pi square. If I take 8 pi square common, what else is left? Cos square and sine square. So what is cos square 2 pi t plus sine square 2 pi t, and therefore vector v is equal to root of cos square 2 pi t plus sine square 2 pi t is 1. So we get root of 8 pi the whole square, which is equal to 8 pi. So what is magnitude of v? Magnitude of v is equal to 8 pi. And here, what is magnitude of r? Magnitude of r here is equal to 4. Okay. So magnitude of v is 8 pi, and therefore we discuss the option D in detail. Now let us talk about acceleration. So when we discuss about acceleration, okay, what is r? Oh, okay, so let me write down these things once again. So we have got r here, right? And what is v? This is v. So we got r and v. So now I think you can differentiate directly without going through much steps in detail. So what is v? What would be the value of acceleration? So acceleration here will be equal to 8 pi into derivative of cos 2 pi t, which is minus sine 2 pi t into derivative of 2 pi t, which is 2 pi into 8 pi is 16 pi square, right? Minus what is derivative of sine 2 pi t? It is cos 2 pi t, into I cap into j cap. Now what is derivative of 2 pi t? It is 2 pi. So 2 pi into 8 pi is 16 pi square. So acceleration is minus 16 pi square sine 2 pi t into I cap minus 16 pi square. Okay, if we take minus 16 pi square common, what is left inside the bracket? What we have is sine 2 pi t into I cap plus cos 2 pi t into j cap, right? So we got acceleration, we got velocity and displacement now. So what is displacement of r? Displacement of r is, we already found it out to be 4. What is displacement of what is magnitude of v? No, not displacement of r, magnitude of r. So what is magnitude of v? Magnitude of v we just found out to be 8 pi. And what is magnitude of a is equal to? It will be equal to root of 16 square, which is 16 square pi square, which is 16 pi, right? So now what I can write a as, see, I can write 16 pi as 8 pi the whole square by 4. Why? Because 8 square is 64, pi the square is pi, and 64 by 4 is 16 pi, right? Why did I write so? Because 8 pi is velocity. So this can be written as v square, and 4 is r. So this can be written as v square by r. So in short, acceleration can be written as v square by r. So yes, that is also correct, which means magnitude of acceleration is v square by r is correct. Now we need to check whether acceleration is along minus r. See, from this step we can say that this much part of the equation represents r. So I can write this as vector acceleration vector is equal to minus 16 pi square into vector r, or otherwise that acceleration is directed towards minus of vector r, in which case the second option is also correct, and therefore we conclude the question here. So this was very detailed explanation. I do understand for those students who are actually don't want this in depth, you can actually look only for the first 1 or 2 minutes wherein the problem is solved with exam perspective. And I always give a detailed solution to ensure that if a person has a doubt on the other options, they don't leave the leave the explanation being confused. So that's why I have written the entire explanation as explainable as possible. Okay guys, so let's move on to the next question. A particle is projected at an angle of 60 degree above the horizontal with a speed of 10 meter per second. After some time, the direction of the velocity makes an angle 30 degree above the horizontal. The speed of the particle at this instant is. It's a really simple question, but is conceptual with respect to the data given. So it is a particle is projected at 60 degree with a speed of 10 meter per second. Okay, so 10 meter per second. So we know that this body will undergo a trajectory of parabolic path. It will eventually land here with the same velocity. We have discussed this in detail, that this will be ux and this component here would be vy, and vy will be equal to minus ui and v will be equal to u, right? And if you resolve this component here, what is this along the horizontal? This is ux, and what do we have along the vertical is uy. And what is ux? Ux is u cos theta. What is uy? It is u sin theta. So now the question says, after some time, let us say here, the velocity can be resolved into vx and vy, and the net velocity is v. Okay, and it makes an angle 30 degree above the, so this angle is 30 degree, right? Which means what is vx? Vx will be equal to v cos 30 degree, and what is vy? Vy will be equal to v sine 30 degrees. Now what we need to understand is, as we discussed earlier, the x component of velocity, right? X component of, or to be more precise, x component of initial velocity remains constant. X component of initial velocity remains constant throughout the motion. Okay, which means ux here is the x component and vx here is the x component. So essentially ux should be equal to vx. What is ux? It is u cos 30. What is vx? It is v cos, oh I'm sorry, it is not 630, it is 60. So it is u cos 60 and it is v cos 30. Now what is the value of cos 60? It is root 3 by 2. What is the value of cos 30? It is, wait, cos 60 is 1 by 2 and cos 30 is root 3 by 2. So what do we get V as? We get V is equal to u by root 3, and therefore V is equal to, what is the value of u? U is given us to as 10 by root 3, which gives us the correct option as option D. If the magnitude of sum of two vectors is equal to the magnitude of difference of two vectors, the angle between the vectors is, see, this is something that we've been repeatedly telling in the class time and time again, that it is very important to make sure that you know the fundamental results, and that we have discussed this class many of times, that if modulus a plus b is equal to mod of a minus b, then the angle between them is pi by 2 or otherwise 90 degree. So the correct option is option B. Now, of course, it's say for example, if you're not able to recollect this during the exam, how do you do this? It's simple. What you do is you write like this, right? Mod a plus b is equal to mod a minus b, and then if you take square on both sides, if you take the dot product on both sides, what do you get? Mod of vector a plus b dot mod of vector a plus b is equal to mod of vector a minus b dot mod of vector a minus b. And what is this equal to? This is equal to a square plus b square plus 2 mod a, 2 a dot b is equal to a square plus b square minus 2 a dot b. And remember, it's a dot b and not a into b, because it's a vector here. So a square and b square will cancel. What else do we have? 2 a dot b is equal to minus 2 a dot b, and therefore 4 a dot b is equal to 0. See, when we say 4 a dot b is equal to 0, 4 definitely is not equal to 0. So then what can be equal to 0? A dot b is equal to 0. Now what is a dot b? A dot b is mod a mod b cos theta is equal to 0. Now, since it is not given in this coefficient specifically that either a or b are non-zero vectors, we can assume that a and b are non-zero, which means the only possibility is cos theta is equal to 0, and cos theta is equal to 0 implies cos theta is equal to cos pi by 2. Therefore, theta is equal to pi by 2. Okay. Now, one common mistake that students make here, let me add a couple of points here. What usually I get as feedback from the class. One common mistake is that students assume that the given question actually means this: mod a plus b, vector a plus vector b is equal to vector a minus vector b. No. These two are not the same. I'll tell you why. What does this imply? This implies that vector a minus vector a plus vector b plus vector b is equal to 0. And vector a minus vector b is 0, which means 2 times vector b is equal to 0. And this is possible only when vector b is equal to 0, or when vector b is a null vector. So vector b is a null vector implies vector a plus vector b is equal to vector a minus b. And mod of a plus b is equal to mod of a minus b implies that the angle between them is 90 degree. There's a difference. Okay. And I will try to add the link for the previous explanation here, which actually gives a very detailed comparison between the different angles and the resultants. But okay, let us not go through another video. So let us just summarize the values, the points here itself. See, so what we have is some additional results that you can use for your future reference, for easy reference maybe. So if resultant is equal to the magnitude of individual equal vectors, I repeat, if the resultant is equal to the magnitude of individual equal vectors, then the angle between them is 120 degree. If the resultant is equal to if the resultant is equal to modulus of p plus q or a plus b, then the angle between them is 0 degree. If the resultant is equal to magnitude of p minus vector q or vector a minus vector b, then the angle between them is 180 degree. Okay. Now let's add one more result for your convenience. See, vector a, we need to use p here, so let's use p. So vector p, modulus of vector p plus vector q, modulus of vector p plus vector q, modulus of vector p minus vector q, and modulus of vector p minus vector q. Why am I writing it 4 times? Because we need the maximum of this, the minimum of this. We need the maximum value of this, p minus q max, p minus q min. Okay, so these are two things that we want. And what does this imply? See, p plus q is maximum, and the maximum value is equal to mod p plus mod q, and this happens when theta is equal to 0 degrees. Okay, and the magnitude of p plus q is minimum, and that minimum value is mod p minus mod q, and this happens when theta is equal to 180 degrees. And mod of p minus mod q is maximum. I repeat, mod of p, vector p minus q is maximum, and this time it's equal to the sum of individual magnitudes of these vectors, and this happens when theta is equal to 180 degrees. And mod of p minus q assumes the minimum value, which is equal to the difference of these vectors, and when the angle between them is 0 degree. So I think these will help you in finding the answer quickly, or maybe going through or at least eliminating some options to to get the correct option fastly. All right, so let's move on to the next question. In the given figure A, which is this vector A, is 15 meter per second square, total acceleration of the particle, radius is 2.5, and the speed of the particle is being asked. See, we know that if this is a net, right, total acceleration a net, and if this is 30 degree, we know that this vector is actually a cos 30, and this is a sin 30. So what is actually given in the question? It is given in the question that a cos 30 is equal to the, so this is a cos 30, right, and this is actually equal to the centripetal acceleration AC, which is nothing but v square by r. So what are we trying to find out? We're trying to find out speed of the particle, right? So what is v square is equal to? So v square will be equal to r into a cos 30. So what is the value of r? R is given to be 2.5. What's the value of a? Is given to 15, and cos 30 is root 3 by 2. Okay, now we have root under root, so let's do some manipulation and make the calculation look simple. So we can write this as 2.5. What I'll do is I'll write it as 25 by 10, right? 25 by 10 into 15 into root 3. See, root 3 is 1.7. So 1.7 by 2 is 0.8. 0.8 I can write it as 8 by 10. So this becomes into 8 by 10. So now what I'll do is 25, 15, 8. What should be easy way to calculate? So okay, let me write like this. 25 by 10 into 10 is 25 by 100. 25 by 100 into 15 into 8. 2500 is 4. 4 2s are 8. So what you get is 15 into 2 is 30. Which means v square is equal to 30. See, though this question is a really simple one, so it took me somewhere around 2 minutes to write it down. Of course, in the examination you don't need to write these many steps, but yet this is slightly time consuming. So if v square is 30, v is equal to root of 30. Let's see, if 5 square is 25, 6 square is 36, so definitely root of 30 will be lying somewhere between 5 and 6. So that option which is between 5 and 6 is 5.7. Now please don't tell me 5, why can't we take 5, because 5 square is 25 and not 30. Okay, so the most appropriate answer would be 5.7. But then we have discussed this question, I think 2 to 3 times. Yet let us have a brief outlook again. So this is a particle executing circular motion in the tangential, in the circular, in the clockwise direction. This is the velocity vector, right? This is the centripetal acceleration, and this also is the tangential acceleration, and we know that the resultant vector is a net, right? So now in the question it is given that for the same condition, what the question says is, it doesn't talk about velocity, it doesn't talk about centripetal acceleration either. What it says is the net acceleration is inclined at an angle 30 degree. So now if you resolve this 30 degree vector, what do you get? If you resolve a net into two components acting at an angle theta, this component would be a cos 30, and what would be this component? This component would be a sin 30, right? So okay, now if you have doubt in that resolution, let me clear that part also. So say if this is right angle triangle, right, starting from here, I can, right, so if this is 90 degree, and if this is, sorry, if this is 90 degree, and if this is theta, say if this is A and B and C, what is cos A is equal to? See, cos A will be equal to, I'm sorry, what will be cos theta? Cos theta will be equal to B by hypotenuse, right, which is A. So what is B is equal to? B is equal to A cos theta. Now compare this diagram. Instead of A, we have here A net. So that we can written as A net is equal to, instead of B, we here have, sorry, instead of A cos theta, we here have A cos 30. So that's how you get A net is equal to A cos 30, and the other way around. If you this goes really basics. I mean, this goes really deep into the basics, but that's okay. It is okay that at times the basics need to be cleared again. So if you for angle theta, if you write down sine theta, what is sine theta? Sine theta is opposite, which is C, by hypotenuse, which is A. So how can you write C is equal to A sine theta? Now while comparing A here, while comparing C here, you have the perpendicular vector C, which is marked here, right? This vector is perpendicular vector. So this is A sine theta, which is A net sine theta, which is theta is 30 here. So this is A sine 30. Okay. So, okay, that was a brief explanation about the concept. Now in the same series, we have discussed about uniform circular motion, accelerated circular motion, and retarded circular motion. Please make sure that those who are here for the first time, please make sure you go to these videos and analyze the relationship between theta, that is between velocity, angle between velocity and A net. That's really important to understand. Okay, having said so, moving on to the next question. The x and y coordinates of the particle at any time are x is equal to 5t minus 2t square and y is equal to 10t. Where x and y are meters, and in seconds, the acceleration of the particle, acceleration at t is equal to 2 seconds. Okay, so in the examination hall, all what we'll do is Vx is 5 minus 4t, Vy is 10, so Ax is minus 4, and Ay is 0, and A is root of Ax square plus, okay, we're doing for the examination purpose, so A is just minus 4, so A is a constant and is not proportional to time, so minus 4 is correct answer, less than 1 minute, as simple as that. But let us now understand how to approach this question. Basic differentiation it is. So it's given to us that x is equal to 5t minus t square and y is equal to 10t, right? So it means that the displacement has two components here, the x component and the y component. So if you differentiate the x component with respect to time, what do you get? Velocity of the body in the x direction. If you differentiate the y component with respect to time, what do you get? Velocity of the body in the y direction. When you differentiate velocity of body in the x direction, you get acceleration of body in the x direction. When you differentiate velocity of y with respect to time, what you get is acceleration of body with respect to time, right? So dx by dt will be equal to d by dt of 5t minus 2 into d by dt of 2 square, and dy by dt will be equal to 10 into d by dt of t. So dx by dt is equal to, see, 5 into derivative of d by dt of derivative of t is 1, so it is 5 into 1 minus 2 into derivative of t square is 2 into t to the power 2 minus 1. Similarly, dy by dt is equal to 10 into d by dt of t is 1. So dx by dt is nothing but vx, and dy by dt is nothing but vy. So vx is 5 minus 2 into 2 is 4. 4 into 2 t to the power 2 minus 1, which is 40, and vy is equal to 10. Now if vx is this 4 minus t, and if vy is 10, if we differentiate further, what do you get? D by dx of vx, and sorry, not d by dx, d by dt of vx and d by dt of vy. So d by dt of vx would be d by dt of 5 minus 4 into d by dt of t, and here it would be d by dt of 10. See, what is d by dt of a constant? It is equal to 0. So this is equal to 0, and d by dt of 5 is also equal to 0. And what is d by dt of vx? It is ax. So ax is equal to minus 4 and ay is equal to 0. So if a vector has two components, ax and ay, then what is the net vector? Net vector is equal to ax square plus ay square. So this will be equal to root of minus 4 the whole square plus 0 square. So a net here is equal to 4 meter per second square. And since ax is equal to minus 4, since there is no t involved here, this means that acceleration is not varying according to the time, or in other words, acceleration is a constant. Okay, now the next question. A particle is thrown at an angle 45 degree with the horizontal. If it remains in the air for 1 second, what is its initial velocity? Very straightforward question. We already have said that time of flight at 45 degree is equal to root 2 u by g. So time of flight is 1 second. So 1 is equal to root 2 into u by g. So u will be equal to 10 by root 2. See, root 2 is 1.4. So I'll write it as 14 by 10. So this will be 10 into 10 by 14, which is 100 by 14. So 114 will be 50 by 7. 50 by 7 is 7 sevens are 49. 10, 7.1. So somewhere near to 7.1 will be the answer. 7.1. Okay, so the answer is 6.93. right? So if you take, if you want to exactly get 6.93, you'll have to choose G is equal to 9.8, and you'll also have to choose root 2 is equal to 1.414. Definitely you get 6.93 answer. But as I said earlier, this is the NEET examination we are talking about, and what we try to do is 1 minute, one question, right? For physics, of course, for physics. So that's how we approach this question in the exam. Now, if you want to understand this in much detail, well, there's actually nothing to be detailed here, but let's see. So what is time of flight is equal to? It is 2u sine theta by g. In the question, it is 1 second. So this is 1 is equal to 2 into u into angle is 45. 2 into sine 45 by g. G is 10. So if you cross multiply 10, 10 is equal to 2u. Sine 45 is 1 by root 2. Again, root 2 into 10 is equal to 2u. So how much is root 2? Root 2 is 1.4. So 1.414 into 10 is equal to 2u. And therefore u will be equal to, u would be equal to 1.4 into 10 by, 10 by 2. So 2 by 10 is 5. So if you multiply 1.414 into 5, 5 4s are 27, 5 4s are 20, 1 5 plus 2, somewhere around 7.070. So 6.9 can be approximated as 7. I don't want to do the calculation with 9.5. That will take that will be unnecessary waste of time here. So let's not do that. Okay, moving on to the next question. A particle starting from rest moves in a circle of radius r. It attains a velocity of v0 meter per second in nth round. Its angular acceleration will be. See, the moment we say angular acceleration, we know angular acceleration alpha is nothing but linear acceleration a by r, is a by r. So we've been asked to find out the value of a by r or alpha. So what I'll do is, I'll first write down the equations of motion, which is, we've been given initial velocity and final velocity, right? Initial velocity is u, final velocity is v0. Okay, so we have v square is equal to u square plus 2 into a into s. Now what we need is not a, what we need is a by r. So I'll divide this equation by r. By r. By r. So what do you get? V square by r is equal to, see, u is 0, which means this term will get eliminated, and what we get is 2 into a by r is alpha, because it's alpha defined here, into s. So what is alpha is equal to? Alpha will further be equal to, v square by 2 into r into s. So v is v0. So v0 square by 2 into r. Is that an option? v0 square by... Okay. So now we need to convert this s. See, what is s in the question? If there is a circular motion being executed, say for example this is a particle, this is center of the circle, and if a particle executes a circular motion here, if it starts from A, it travels like this, and it travels like this, and if it eventually reaches A, one revolution is completed, right? One revolution is completed, and if this was the first vector position, once it completed, see, it will move like this, right? The vector at every position, the vector will move like this. Eventually, the vector has moved this much, right? So what we can say is one revolution, displacement in one revolution is actually 2 pi r, because it has moved this complete distance, and this distance is actually the circumference of the circle. So if displacement in one revolution is 2 pi r, what is displacement in two? Okay, write it down again. So if displacement in one revolution is equal to 2 pi r, then what is the displacement in two revolutions? It is 2 pi r into 2. In which case, what is the displacement in 3 revolutions? It is 2 pi r into 3. So what would be the displacement in n revolutions? It would be 2 pi r into n. Therefore, S here is equal to 2 pi r into n, and hence alpha will be equal to V0 square by 2r into what is S? S is 2 pi r into n, which is therefore equal to V0 square by 2 into 2 is 4 pi r into r is r square, 4 pi r square n. So the correct option is option C. Now, this is a really good question. See, always be ready to, and always be ready to be surprised by the NEET, because there may be some questions which you have not practiced otherwise and which may take only a couple of minutes, or maybe, or see, I'm explaining here, that's why it took somewhere around 4 minutes. If this were to be done, in absolute silence, in a pure examination environment where I'm not talking and only the pen is being scribbled on paper, then definitely take less than maybe a maximum of 2 minutes. So some question may take 2 minutes. That's why I say it in every question, that the moment you say a question can be done within 1 minute, you're saving time for these kind of questions. Okay, so all right, so we've done 10 questions in 2019. A couple of more questions left. Let's see that also.